Beautiful, beautiful. In this episode, we're going to show and compare our ways to modify your hardline tubes to get the best illumination possible out of them.
All right, Jacques, this build is for Brittany. She's really into rainbows and unicorns, Rainbow Bright, RGB lighting. So we thought we should illuminate the hard tubing in this build. And currently on the market, there's two different offerings to do that. That's Thermaltake's Pacific RGB compression fittings or Alphacool's hard tube RGB ring.
The rings are actually something that would fit in conjunction with another compression fitting anywhere on your hardline tube. So that gives us a nice set of flexibility. And of course, a compression fitting from Thermaltake that goes on the caps of our tubes like we would any other compression fitting. So we want to take a look at those, how they compare with each other, how they actually light our tubes up, and what we can do to actually get the best illumination out of those tubes, how we need to modify them, etc. So let's take a look at that now.
This is Alphacool's hard tube RGB ring fitting. It's not a compression fitting. It's very easy to use. It slides right over the tube, and it's available in two sizes for either 16mm OD tubing or 13mm OD tubing, which is the same as 1/2 inch. Now, the other option we had for an RGB hard tube fitting at the time of this recording was Thermaltake's Pacific RGB fitting. This is actually a superior design to the Alphacool one in that the LEDs project through the edge of the tubing, making the light extend much further than the Alphacool.
So we're going to score the inside of one of our PETG tubings, so that way we can actually get the RGB lights to refract after they go through the tube instead of refracting on the outside of the tube, so that the light actually gets to enter and stay in versus getting rejected.
So what Jacques is doing is cutting up red Scotch-Brite pads, medium grit, so we can perform two different types of surface effects for our lighting experiment. The first is we're going to use the red Scotch-Brite pad to scuff the outside exterior of our clear PETG tubing, which has been done on this piece already. All you have to do is just wrap the Scotch-Brite around the tube and just scuff away until you have a consistent frosted look to the exterior. The other surface effect we'll be doing is scuffing the inside of the clear PETG tubing. And so what Jacques has done is cut this piece of the red Scotch-Brite into a 1/2 inch by 6 inch long strip, and I've taped it onto this 1/8 inch diameter aluminum rod that I got at a hardware store, so we can insert this into the tubing via a power drill and scuff the inside all the way through and back.
Yeah, either a gun barrel cleaner or something else that we could send down the tube with a butterfly at the end.
So here's what our tubing looks like after we've performed the internal scuffed surface effect to the PETG tubing. Next, what we're going to do is compare this surface effect to the scuffed exterior effect to see which one produces the best lighting effect overall.
So our first two tubes here for the test are perfectly clear. We haven't doctored them in any way, and they're empty. Our next two tubes with the Alphacool on the left and the Thermaltake on the right have been scuffed only on the inside. And then our last two tubes over here are scuffed only on the outside, again with the Alphacool on the left and the Thermaltake on the right. So we can see with no liquid in them thus far is that the ones scuffed on the inside actually radiate light the farthest up the tube. Now if we take a look at the ones who are scuffed on the outside, they actually are the brightest, but they only make it about halfway. And our clear tubes, well, they're just clear. Let's take a look at what they look like with liquid in them. What we figured out here is that the liquid actually enhances the color that's running through the tubes. You can tell now with the inside scuffed Thermaltake Pacific RGB hard lighting fitting that it's illuminating all the way from down here to the top.
What about flow rate? Is scuffing the inside of the tubes going to hurt flow rate at all?
Absolutely not. So if we take the look at inside of any fitting or any block or radiator, none of those are perfectly smooth. And the amount of scuffing that you do into PETG to make it have this effect isn't going to affect flow rate at all. But we do need to make sure that we flush these tubes fully with soapy water and get them fully dried out before we actually use them in our builds. All right, so an in-depth look here after we've actually bent the pipes so we can see how they would react when actually in a system here is we have our first two now set up with the scuffing on the outside, and this is the Thermaltake and then the Alphacool. And then our next two are going to be scuffing on the inside with the Alphacool and then the Thermaltake. Across the board, the one that has the most light or the luminosity that's gone the farthest through the tube is the one with the scuffing on the inside and the Thermaltake fitting. It's actually gone to the point where the top ring is still highly vibrant. Where if we look at any of the other rings at the top, we basically have nothing. The outside gave us a very nice, bright, hot spot right outside of the fitting. The inside, though, I think is how we both prefer it, and the inside allowed the entire tube to refract all the way down.
Yes.
So it kept a more consistent light profile through the entire length of the tube. And I think that's the way that we will go forward in our build. So one side note for this is please flush out any of that tubing after you've scuffed it, because we want to make sure that this is not clogging up our blocks or our radiators. And
also, if you have any suggestions for a different technique of scoring or scuffing the inside of the PETG tubing other than what we've shared, let us know in the comments. Or if there's another RGB type fitting out there that you know of, also let us know in the comments and we'll check it out.